Yesterday, we learned that neurons connect in layers to form a neural network, and each layer detects increasingly complex features. Today, we ask, what if we go even deeper? What if instead of 3 layers, we use 50 or 150? That is deep learning, and what it can do will genuinely shock you.
So, what is this big idea, really? Well, at its heart, deep learning is just using neural networks with many, many more of those hidden layers we talked about yesterday. The best way to think about it is like peeling an onion. Every single layer you peel back reveals a deeper, more abstract understanding of what you're looking at.
Okay, so let's get a formal definition down. Deep learning uses something called a deep neural network. And you know what? The key word here is just deep. It literally just means the network has a whole bunch of layers stacked on top of each other. It's not some brand new complicated magic, it's just more of that powerful structure we already know. More layers simply means more power.
Now, this is where that whole onion idea really comes to life. So imagine a computer looking at a photo of a cat. The very first layer, it sees nothing but a grid of raw pixel values, just numbers. Pretty useless on its own, right? But then, maybe by layer 5, it's starting to see something. It's combining those pixels to find basic edges and curves. Go deeper to layer 12, and now it's piecing those edges together to see textures like fur. By the time you get to layer 30, it's identifying actual parts, an eye, an ear, a whisker. And finally, that last layer puts all those pieces together and makes the call, that's a cat. The most amazing part? We never told it to look for fur. It figured that out all by itself.
You know, this idea of deep networks wasn't exactly new, but for decades, we just didn't have enough data or the right computer power to really make it work. Well, that all changed in 2012. This was a moment that was basically the big bang of modern AI, and it all happened at a competition called the ImageNet Challenge.
So the challenge was pretty straightforward. Build an AI that can look at a random photo and correctly say what's in it, choosing from over 1,000 different categories. Simple to say, but incredibly hard to do. By 2011, the absolute best AIs in the world were still making mistakes about 26% of the time. Progress had just stopped. It really felt like we had hit a massive wall.
And then came 2012. A small underdog team from the University of Toronto entered a deep neural network called AlexNet. No one really expected much from them, but the results, they were absolutely jaw-dropping. As you can see right here on this chart, while everyone else was stuck at a 26% error rate, AlexNet blew them away with an error rate of just 15.3%. This wasn't just a small improvement, this was a fundamental breakthrough. It was like an unknown cricket team showing up to the World Cup and not just winning, but completely changing how the game is played forever. And that was the moment. After AlexNet's victory, the entire field of AI changed, literally overnight. Giant companies like Google and Meta completely pivoted their entire strategy towards deep learning. The crazy AI explosion that we're all living through right now, its origin story starts right here in 2012.
So, okay, a big competition was won. But what does that actually mean for us? What did this revolution actually give us? What kind of new superpowers did we unlock because of this one single breakthrough?
Just think about it for a second. Unlocking your phone with your face? That's deep learning. Siri or Google Assistant actually understanding what you say? Deep learning. Remember when Google Translate suddenly got incredibly good a few years back? Yep, that's when they switched to deep learning. Even DeepMind's AlphaGo, which beat the world's best Go player, something people thought was decades away, was powered by this exact same idea.
And this goes way beyond just convenience. In medicine, this stuff is literally saving lives. Deep learning models can now analyze retinal scans and spot diabetic retinopathy, which is a leading cause of blindness, with 94% accuracy. That's a level that matches and in some cases even beats specialist human doctors. Incredible. So if you only remember one thing from today, please let it be this. The entire secret of deep learning, the reason it's so unbelievably powerful, can be boiled down to a simple 3-word formula.
Depth equals abstraction equals power. Adding more and more layers, that's the depth, allows the network to understand more complex and abstract ideas, like going from seeing pixels to understanding the concept of a face. That's the abstraction. And this ability to grasp abstract concepts, well, that's what gives AI its incredible problem-solving power. That's the whole secret right there.
Tomorrow, we leave images behind and enter the world of words. How does AI understand human language?
How does it know what you mean when you type a sentence? That is natural language processing, and it is the bridge that leads us all the way to ChatGPT. Episode 5 is tomorrow. See you there.